Mesoisomer and its optical inactivity. This is today's lesson. In this lesson, we are going to learn what is mesoisomer and whether this is optically active or not. So, let's get started. Mesoisomer is formed from an organic compound having two similar chiral centers. Let's write a compound having two similar chiral centers. COOH, CHOH, CHOH, COOH. Its name is 2,3-dihydroxybutane dioic acid. Let's write the name of this compound. Its another name is tartaric acid. Let's see two similar chiral centers in this compound. COOH, CHOH, CHOH, COOH. This is one chiral center, this is another chiral center. Groups at this chiral center are carboxyl group, hydroxyl group and hydrogen. And groups and atoms at this chiral center are carboxyl group, hydroxyl group and hydrogen. Same groups and atoms. So, these two chiral centers are similar chiral centers. Mesoisomer is formed from an organic compound having two similar chiral centers. Let's see the matter in detail. Let's write isomers of tartaric acid. COOH, here HOH, here HOH and here COOH. This is one optically active isomer of tartaric acid. Let's write another isomer that is mirror image of this isomer. Let's write COOH, C, here HO, H, here H, OH, COOH. These two isomers are optically active isomers of tartaric acid. This isomer rotates the plane of the polarized light towards right, clockwise direction. That is why its name is dextrorotatory tartaric acid or simply D-tartaric acid or plus tartaric acid. And another isomer which is mirror image of this isomer that rotates the plane of the polarized light towards left, anti-clockwise direction. That is why its name is levorotatory tartaric acid or L-tartaric acid or minus tartaric acid. Let's write another isomer formed from tartaric acid. COOH, CHOH, CHOH, COOH. This is another isomer of tartaric acid. At the middle of this isomer, let's consider a plane that divides this compound into two halves, in which one half is mirror image of the another half, and these two halves are non-superimposable. That is why one half rotates the plane of the polarized light towards right clockwise direction, and another half rotates the plane of the polarized light towards left, that is anti-clockwise direction. In this molecule, two halves cancel their opposite rotations. One half rotates plane of the polarized light clockwise direction, and another half rotates plane of the polarized light anti-clockwise direction. One half cancels the rotation of the another half. That is why this compound actually cannot affect the plane of the polarized light. The activity of this compound is called internal compensation. And meso means middle or intermediate. At the middle there is a plane of symmetry. The imaginary plane divides this compound into two halves, in which the two halves are identical or symmetrical to each other. That is why this imaginary plane is called plane of symmetry. Let's write the term plane of symmetry. Because of this plane of symmetry, this isomer cannot affect the plane of the polarized light. That means this isomer acts as optically inactive compound. Because of this internal compensation, this isomer is optically inactive. So meso isomer is a kind of optically inactive compound. The main point is here, in this compound there is a plane of symmetry between two chiral centers. One half is non-superimposable to another half, where these two halves are mirror images of each other. One half cancels the rotation of the plane of the polarized light occurred by other half, and other half cancels the rotation of the plane of the polarized light of the opposite half. Ultimately, this compound cannot affect the plane of the polarized light. That is, meso isomer acts as optically inactive compound. This is all about meso isomer and its optical inactivity. No more today. Thank you very much.